Hello and welcome to a new video series here on the Ludwig Fusel channel. The long-awaiting C++ beginners tutorial is finally here. So I often get the comments like, hey, can I do your Unreal Engine tutorials even if I don't know C++? And I always respond, yeah, if you have some knowledge in Java or any other programming language, go along, see if you can follow it and try to understand it, or maybe watch some different tutorial videos. Well, now I no longer need to say that. Now I can say, hey, here's the playlist, watch my C++ beginners tutorial. And that's good. The request was there, I've got the comment multiple times, and I always felt like I want to do it at some point, but I was never quite sure how to do it, but I now finally am there. I'm finally here, we're gonna do this tutorial series, we're gonna do an hands-on tutorial series for beginners. You don't need any pre-requirements, any other knowledge, you can start from scratch even if this is your first programming language. And actually, if this is your first programming language, if you say, okay, C and C++, I've never programmed before, don't let you lure from like Python, Java, C#, Visual Basic, .NET, Lua, whatever. Don't let you lure into these programming languages. C and C++ are great. And if you learn them correctly and if you understand them correctly, your life is going to be a hell of a lot easier. Because if you know C and C++, you can write Python, you can write Java, you can write Lua, PHP, everything. Because C is kind of like the mother of all languages. Like C, it's not the mother because there were different programming languages before C, but kind of like the first real and massively used programming language was C, and then there were like these whole variates that went out from that, like C++, some people write Python, PHP, Pascal, Ruby, but it's like at some point everything goes back to C. Not everything, but most things. And by knowing C and by knowing all the logic that is required in C, you can then easily transition to any other languages. So if you are a beginner, this is your first programming languages, stay with me. I'm also going to tell you what is bad at C and C++ in this video here. But don't let you scare away. It is a massive chunk of work that we have in front of us, but it's also good because you can learn and you can do much stuff. But let's actually go one slide ahead and take a look at what we do. So a few infos before we start the real tutorial series where we install our IDE and then get started programming. What should you know when you start this tutorial? Well, I basically said you don't need any knowledge for that. This is kind of true. But of course you should understand English. If you don't understand it, you probably don't watch this video, but you should understand what I'm talking and you should be a power user. So if you just got your first computer and it's like the first YouTube video you watch on your computer and you have done no programming, you basically just have a plain Windows installation, you not have even installed Minecraft or something like that, this is probably not for you. I do actually require you to know how to use your computer. You need to know how the file system works, how to create folders, how folders work, that you can like go a folder up and then you have like a directory above that directory we're currently in, how files work, how relative file paths work, how absolute file paths work. You should know how your computer works, your file system, how to go in your settings, how to fix something if something is wrong with your computer, how to install Windows updates, how to set up your Windows correctly, what this admin prompt is all about when you're trying to install an application. You should be kind of like a power user. You should not be the average user that says, oh my god, I need an application. Hey, Dad, can you install that app, please? No, you should be the power user that is using the PC already. And ideally, but not required, you also have some programming experience. Or at least logical experience. How to solve problems and stuff like that. So my ideal candidate would be a Scratch programmer that has played a few games on his computer, that knows how to write like Word, how to set up Word correctly, how to use Excel, maybe has already have some calculations in Excel, done some graphs in Excel, has maybe written a PowerShell script or a batch script to delete some files or move some files around, and maybe has used Scratch or any other visual programming language, or maybe even Unreal Engine blueprints to basically get into the thinking of how computers and software engineering work. So this is ideal. If you have not done this, You can still try this series. I'm trying to do this step by step. It can be that, especially in the next video when we're installing it, I'm quickly rushing through all the applications that we install, and you might need to pause at some points in the video. You might need to maybe go back in the video. You might, the speed that I might put into the videos might be too fast for you, but just try it. If you never try, you're never gonna succeed, and this is important. So even if you think, oh no, maybe C++ is and C is not the right thing to start, just try it out. Waste a few hours of the first videos. Waste them. If you afterwards say, okay, maybe I'm not as far to learn this, you can stop anyways, but try it out. Don't be scared by big C and C++, which is like, if you ask people, say, oh my god, C++ is so complicated, C is complicated, all these pointer templates, oh no, then the compiler gives so much errors, it's so hard, I'm gonna just use Python. No, don't think like that. Try it out, learn it step by step with me, and also try to exercise during my videos, try to do your own projects, and try to make the best out of that. Because if you know that, I know it's a hard chunk, I have learned it at some point by myself also, not learned this in school. I've basically learned this the hard way, like buying books, getting lost in books, trying YouTube videos, getting lost in YouTube videos, trying to write my own applications, were confident, worked, changed something, all broken. Did not work. Compiler issues, did nothing work. Completely project screwed up, no idea, deleted the project, go to the corner and cried. This is how I learned that stuff. But try to do it the same way, even if it's hurting. But when you have done this groundwork, if you have done the foundation with C and C++, you're gonna be a hell of a lot more valuable as a programmer, software engineer, whatever. For example, I never learned software engineering, and I already had 4 or 5 projects, software engineering projects in the company I'm working for. Even through our department is not even doing classical software engineering. And they still wrote tools, and everybody is like, oh, our old tool was written by somebody else and it's so slow. Can you try to reduce so that it doesn't take 5 days, just 1 day? And then should they say, sure, yeah, I'm going to do it in maybe 1 or 2 minutes so the application runs fast. And yeah, people are going to love you if you can program, even if you're not going to be a software engineer in future. I am actually currently studying electrical engineering and also working as an electrical engineer in a company already. And it's still boosted my valuability even though I'm not a software engineer. So that really helps. So getting to the next thing, why C and C++? Well, first of all, we have 2 languages in here. C is a language and C++ is a language. Why is this tutorial containing 2 languages? Well, because C++ is C, but with 2 pluses. It has been extended. And now I'm getting whined in the comments and people try to beat me, try to find my address to get up to my house and beat me down to earth because I said that C++ is a superset of C. However, it's not. The thing is, C and C++ are 2 different languages, but C++ maintains full compatibility with C. So if you have some C code, a C++ compiler shall be able to compile this. You should be able, if something is written in C, to use it from C++. In theory, you could even use something that was written in C++ and write some wrapping stuff around that so that it can be used in C. So these things are kind of intercompatible. You have some issues sometimes, but at least they work together. And this is why we're gonna start with C and later on transition to C++, because everything we're gonna learn in C, and I'm trying to adapt the few special utilities that C brings. So C has a few things that work different than in C++, but they are minor, or at least like in C++ you do it the other way, but the C way still works. But the Microsoft compiler is a bit, that we're gonna use is a bit less strict and allows us to use the C++ way in C. And this is why we're going to start with C. And in C we can do simple applications, we can learn everything on a very, very simple, tiny set of features. And then when we understand C and all the concept of like functions, data type, header and source files, variadic functions, what else do we have? Like structs, libraries. If we can basically learn this all in C the easy way, and then we can move to C++ with all of that big knowledge, and we can start extending this with like classes, object orientation, interfaces, templates, the standard library that brings us a hell of a lot of features, and so this is why we go that path. Now you could ask, yeah, why do you even use C, C++? Why don't you use like Python, Java, Lua, Ruby, PHP, whatever? Well, first of all, the main difference between C, C++, and many other languages is that C++ is compiled. What does that mean? Well, when you write your application, you're going to start in like a text file. It has a special ending, that file, but you are starting in a text file and you write down the code. So what the application should do, you write it down in this special C, C++ language, and then you click a button in your application, your so-called IDE, the Integrated Development Environment. So basically just a fancy text editor that allows you to basically do one click and then the application is magically transformed into an executable. And this magically transforming is called compiling. So the text file is read by a application, by a program on your computer, and it's going to be turned into binary information that the CPU, the operating system, Windows, can load and execute on your machine. And basically, by doing this step, you basically take a big chunk of work away from the runtime. So at runtime, you just execute the program. It's just read instruction by instruction in a machine language that the computer can understand, and it works. On the other hand, languages like Python use a so-called interpreter. So the interpreter basically reads the source file at execution time. So at the time where the user starts the application, your file that you have written, the source file with all the English, PHP, Python style expressions. So if that is the case, then do that. If not, do that. All that, including all these keywords and all these language constructs, are read at runtime and interpreted at runtime. So at runtime, everything is parsed, analyzed, the comments are skipped. It's all analyzed and thrown through the application. And this makes languages like Python and PHP slow. Because basically, if you're just doing a simple addition in C++, it's just an addition. So 1 + 1 = 2. It's just an addition. On Python, it's like, read that line. Oh, I found a 1. Oh, I found a plus. Oh, I found a 1. Okay, this seems to be a math equation. Let's parse this at math. Okay, math detects the plus sign. Okay, what is on the left side? Oh, this seems like it's a number. This is detected as number 1. What is the right one? Oh, this is a number. This is detected as number 1. Okay, stored somewhere else. Now I have these two numbers. Now do the addition. Basically, this is how like Python works, while C++ just says 1 + 1. So it is faster, more efficient, uses less memory, more controllable, everything. You get like many features. But on the other hand, if you use Python, you can, of course, do it much more easier. You just need to write a file and download Python. You don't have any step like compiling your application and making sure that it runs on every system, because this is all handled by Python. If you run a Python file on a Mac or on a Linux machine, it is by default working the same than on Windows. Asterisk, of course you can break Python so that it only works on Windows by using special functionalities, but by default Python can run everywhere, while C++, if you just compile it for Windows, the file that has been produced is just for Windows. Surely, if you want to run this on a Macintosh or on a Linux system, you can just take your source code and run it through a different so-called compiler, so a different application that translates your text, your source code, into this machine-readable binary format. You can use a Linux compiler, and then you get like a Linux executable that can run on Linux. You do the same for Macintosh, you get one for Macintosh. But to do this, you need, of course, all of these applications. And for example, to compile applications for Mac, you need to have a Macintosh, because you need to have Xcode installed, so you need to have a physical iMac, because Apple wants you to have a physical one to be able to do that. So you need a physical Mac to do this. While on Python, you just test it on Windows, and if you are just using Python default functionality, just give the script somebody else, and they should be able to run it everywhere. For example, my applications that I have written have never worked on a Macintosh because I don't have a Macintosh. If I would maybe write this in Python, it would work. On the other hand, Java, a programming language that uses a so-called virtual machine. A virtual machine, it's similar to what Python does, but it's basically also binary. So Java source code is not compiled into a machine-readable machine code. It's compiled into a intermediate binary format, a so-called, I forgot it, Java bytecode or something like that. And this Java bytecode is a portable format that can be executed on the so-called Java virtual machine. The virtual machine is basically just emulating a different computer on top of your computer. So the Java VM has been written in C and compiled for Windows, Mac, Linux, and maybe some more other systems. So it has been already written, built, and compiled for that specific operating system, for that specific machine, and it is ready to be installed on each machine. And then each machine, if they have Java installed, can run Java applications because they are emulating a virtual machine that is on all operating systems the same on top of your system. And this makes Java, for example, portable, but also, of course, slower. And that is why we're gonna use C and C++ because it is native to the system. If you later on need these portability features, or you have an employer that says, hey, we need Java developers, you can do it. The syntax between Java and C++ is not that different, even through C++ has a complete different approach to like objects and how objects are allocated. But these are all things, if you understand C++ and C, you just need to read you into Java, or maybe just watch a few videos to Java and you are set. You can use Java, and if you are going that route and you completely learn C and C++ extremely well, and not even only that, even all these software engineering skills, you're gonna get so many things for free. You're gonna get like the error diagnostics. On C++, you're gonna have a hell a lot of errors. Compile time errors, runtime errors, link time errors, IDE shown errors, crazy errors, uncrazy errors, ridiculous errors, whatever. You're gonna have so many types of errors, some that you don't know, some that you directly know, by just reading the message, and you're gonna spend a hell of a lot of time on the internet trying to find out what each error means. But this is not a bad thing, because you're gonna learn how to find out fast what went wrong. And if you get the skill that you can easily find out why something didn't work, you also get the skill to find out how something worked for free. You get the skill to use documentations, official documentations. You get the skill to read them for free, and you get Google skills for free, how to use Google correctly to give me all of my results that I want. And if you have all these skills, you can get like Java up and running in a few hours, even if you have never touched it before, because you have all the skills required. For example, we had a discussion on Python recently where we were discussing like the power operator. So in Python, if you do the double stars, you basically can do x power 8. So 2 over 3 or 3 over 3. You can do this with a special operator in Python. And we were discussing how this is implemented. And well, I just said, okay, I think it's implemented like that. And others were saying, no, I think it's like that. And there was like, okay, let's try to find it out. So just a quick Google search, found the Python source code, found the right file, opened it up, take a look at the implementation, and I was right. Python, for its power operator, just uses the plain C++, the plain C power function. I'm gonna get to that, what functions and stuff like that are. But yeah, this is like you get skills for free. So that is why C and C++. How is the approach of this tutorial? Well, we're going to start with C. I already told you that. We're going to start very, very slowly with C. Going to go advanced to C until we get like all of the C features out, the C features. And then we're going to transition smoothly over to C++ without you noticing. Okay, I'm going to tell you, but you're going to see that the transition is going to be very smoothly and very natural, and it gives us more power. And that's amazing. So next video, we're going to talk about how you set up your machine. We're going to install everything, actually including a JDK, including installing Python. It seems very controversial. The first thing we're going to install is Python, and then we're going to install Java before we even get to installing like C and C++. I'm going to explain this next video why, but because the thing is we need these as development tools. There are so many tools written in Python that are basically used for C++ development, like package managing and more stuff that I don't want to go into it. But basically people use Python to automate their C++ steps. And this is actually where Python is totally fine for stuff like that. Automating your C++ stuff. Using it as a scripting language. Using it for like math people to find out the new fancy function and distributions. Numerical methods. Scientists. But at some point you as a C++ developer get the Python scripts built in front of you and they tell you, hey, I'm a math guy. I have found out this new amazing algorithm. Can you please make it fast? It should run like 500 times a second. And now in Python it takes 500 seconds a time. Can you solve that? And then we are sitting there and say, of course, we can do it. So that's what you get from this tutorial series. So thank you for watching. Stay tuned for the next one and make sure to like and subscribe, of course. And have a nice day. Bye.